Okay. Now that we have completed the ambient measurements on the 3 sets of samples, we're ready to do an elevated measurement. But before we do the elevated measurement, we need to look at the data that we've created with the ambient measurement. So we will click on our screen where it says data, and we're going to create an Excel data file. And we select from our drop down for this sample was called IMS set 5, sample A, and we can see from the select runs that there is both a load and an ambient measurement that has been made. Notice that before you are able to do an elevated measurement, you must do an ambient measurement so that there is a measurement to normalize to. So I'm going to click on OK, and an Excel sheet is being written with the data. Click on that, and I'm going to maximize it so we can look at the data. We've got first our load dependent data, and then we have our ambient data. I am going to write down the transit time for our shear wave measurements, and we're going to do a V31, so the transit time is about 7.8 microseconds. And I'm going to just make a note of that, 7.8 microseconds. That's going to be important because it is a little bit unclear where the measurement point is for a shear wave elevated temp measurement. The compressional is always the first peak, but the shear is a little more difficult to find out. So I'm going to write down the 7.8. I'm going to close the Excel file. I'm going to select elevated, and this brings up our configure sample window. I'm going to go into run setup and select elevated measurement sequence, and the mode I would select maybe is the V32. In order to find out what the transit time of the buffer rod that you need to add to the 7.8 microseconds, you'll need to go into the advanced button, and there will be the buffered transit times listed there, and you'll simply add. It's usually somewhere 20 microseconds to 26 microseconds, and you'll add that to the 7.8. All right. To do a 3.2 measurement, we place, or a 3.3 elevated measurement, we place the sample in the holder with the larger opening, and then the sample gets inserted into the heater cartridge, like so. We have, for shear wave measurements, we have special shear wave couplant, and for the compressional wave measurements, we have a special Sano 600 couplant. We have found that if you supply enough load for these measurements, that it is not necessary always to use the couplant for the elevated measurements. So once the sample is in the holder, in order to do, say, the buffer rods, the transducers and the buffer rods will, on either side of the sample, will manually apply the load. The stem of the transducer is up. This would be a V31 measurement, and there is a stop there, so usually we do a V31. If the transducer is rotated this way, this would be a V32 measurement. If it's a compressional transducer, the orientation does not matter as much. Okay. We also have a different holder for the V22 and 21. This has a smaller opening, and that slides into our heater, same as the other holder. And again, the stem would go in the pointed up direction for a V21 measurement, or if it's the compressional transducer, the orientation does not matter.